So we've looked at division as splitting out into equal groups of, we've looked at standard algorithm a little bit, and we've looked at base 10 blocks. So I want to go back and revisit standard algorithm some more since that is the focus of today's TEK. And then I want to go over one final way that's based on the area model, and it's a way that I actually really like. Alright, so for the next one, let's look at 1,283 divided by 5. And again, I like the grid paper or sideways notebook paper. It keeps our columns nice and straight. So let's write our steps. Does McDonald's sell cheeseburgers? Divide, multiply, subtract, check, and bring down. How many 5s are in 1? 0. How many 5s are in 12? 2. 2 times 5, 10. Subtract, check, that's good, and then bring down. How many 5s are in 28? 5 times 5 is 25. It gives me 3. 3 is less than 5. Bring down. And if I'm going too fast, definitely feel free to pause the video and work at your own pace. There's 6. 6 times 5 is 30. Subtract. And now I do have a remainder, and there's nothing left to bring down. So 256, remainder 3. Now there's a couple things we can do with the remainder, and I'll focus on those in a future video. But for now, 256, remainder 3 is going to give me my answer. But I do want to multiply to check. 256 times 5. And then I have to remember at the end, I'm just going to add in my remainder. So when I'm done, I got to add that back in. 6 times 5 is 30. 5 times 5 is 25 plus 3. 5 times 2 is 10, 11, 12. And then I need to add my remainder 3. 1, 2, 8, 3. And I am back where I needed to be, so that answer is good. Now what happens if I have a much bigger divisor? So let's look at 413 divided by 45. Now before, all the other questions that we've done before are not 5th grade level questions. They're actually lower grade questions, 3rd and 4th grade questions. And now we're going to be looking at 2-digit divisors. And so now we're going to start looking at the 5th grade and beyond level problems. How many 45s are in 4? There are 0. How many 45s are in 41? Again, 0. How many 45s are in 413? I'm back where I started. Let's see. So what do I do here? What I recommend, what I always do is I kind of make a T-chart. What I'll do is 1 times 45 is 45. 2 times 45 is 90. 3 times 45, so I could just add these, right? 9, 10, 11, 12, 13. 4, so add another one. And just continue doing that. So that is one way of doing it. But again, what ends up happening is I just got to keep going until I figure it out. Another thing that we can do is we can estimate. Yeah. How many 40s are in 400? Well, there's 10. So I know it's a little bit less than 10. So maybe it's 9. We can just try that and see. So 45 times 9, and let's just see how close that gets us. So that way I'm not just sitting here, and you can just keep going down 5, 6, 7 until you get it, and that's perfectly fine. But that estimating helps me to try to narrow it down much quicker. So 9 times 5 is 45. 9 times 4 is 36, 37, 38, 39, 40. 405. That looks like that's going to get me there. So 9 times 45 is 405. Subtract. So 13 minus 5 is 8. And I have 9, remainder 8. And so, yeah, that was a little bit much, a little bit difficult maybe for some of us, but that's okay. In just a few minutes, I'm going to show you another way. So yeah, our focus on our TEK is standard algorithm. That's what we have to know how to do, but I'm going to show you another way for problems just like this where standard algorithm's a little bit much. Let's do one more and then I'll show you this other method. 1,980 divided by 55. So again, I'm probably going to be able to estimate. So that's about 50. This is 1,900. So if I had $19, how many 50 cents is in $19? So it would be double that, right? 38. So about 38 times. Okay. But maybe I don't have to go that far. Let's just take a look and see what we can do. So the point is there's several ways that we can attack these problems. How many 55s are in 1? 0. How many 55s are in 19? 0. How many 55s are in 198? Oh, there are some, so I didn't have to do the whole thing. So how many 55s are in 200? There's maybe 4, maybe 3. I'm not really sure. So instead of doing the whole t-chart, let me try 3 and try 4 and just see what that gets me. So 55 times 4, I'll try the bigger one. 4 times 5 is 20. 4 times 5 is 20 plus 2. 220, that's too many. So 55 times 3. 3 times 5 is 15. 3 times 5 is 15 plus 1. So 165, that looks good. So 8 minus 5 is 3. 9 minus 6 is 3. 0. And then I check. Is 33 less than 55? Yes, it is. So I'm ready to move on. Bring down. Now how many 55s are in 330? Well, how many 50s are in 300? And so that would be 6. So I could try 6. I could try 5. Let me try 5. 5 times 5 is 25. 5 times 5 is 25. Plus 2 is 27. Gives me 5. That gives me 5 again. And, oh, look at that. I check. Is 55 less than 55? No, it is not. So I didn't do enough. So maybe it's 6. 55 times 6. And I always recommend, when doing long division, write lightly and make sure you have a good eraser, because you will make mistakes. And that's okay, because mistakes are part of learning. 6 times 5 is 30. 6 times 5 is 30 plus 3. And, oh, that's exactly what we need. All right. 6 times 55 is 330. Subtract. And so my answer is 36 with no remainder. And, of course, we can always check that. 36 times 55. I always like writing the bigger number on top. You don't have to. That's just something I like doing. 6 times 5 is 30. 6 times 5 is 30 plus 3. Tick, tack, 0. 3 times 5 is 15. 3 times 5 is 15 plus 1. And I'm back where I started, and so that is a good answer. So 36 is my quotient. Let's revisit our area model with a couple of questions that we looked at before. So I had 378 divided by 9. So I know in my area model, if I could make some sort of array, a rectangle, and I have a side length of 9, whatever the other side length is, as long as my area is 378. So 9 times whatever number goes here is 378. That's going to give me my answer. So if I take that approach and just say, well, I have no idea what this side length is. So I need to find out that side length. I do know one side length is 9. So I know the whole amount has to be 378. So what I can do is I can try to look for numbers that I know will fit into here. Now this is going to seem a little weird probably at first, but just bear with me. Hopefully it'll make sense. I need some number that's going to fit into 378 that is a multiple of 9. So 9 times 3 is 27, so 9 times 30 is going to be 270, right? We can agree with that. 9 times 3 is 27. Bring over my 0. So 9 times 30 is 270. That's going to give me part of it. Not the whole thing, but that's okay. I'm just going to keep working on pieces of it until I get all of it. Well, I had 378. I've found 270 of it, so let me see what's left. So 8, 0, 1. All right, so how many 9s are in 108? So I know there's 108 left here, and I'm not sure, but I know that 9 times 10 is 90, so I found another part of it. I know there's still a little bit more. So 9 times 10 is 90. So 90 minus 100, or 108 minus 90 rather, is going to be 18. And then how many 9s are in 18? Oh, that's easy. There's 2. There's 2 9s in 18. And so now I've found all of my pieces. And so this side length over here is going to give me my answer, my other missing factor of what I multiplied by 9 to get 378. So it's 30 plus 10 plus 2, and so that gives me 42. So that means that 42 times 9 should give me 378, and of course we could always check. 9 times 2 is 18. 9 times 4 is 36 plus 1, 37. So 378. That is a correct answer. Maybe that seemed a little weird. Let's try it again on a problem that we've already done just to confirm. So what about that one that I said was a little bit weird? That was 45 divided into 413, or 413 divided by 45. That one was difficult because how many 45s are in 4? 0. How many 45s in 41? 0. How many 45s in 413? I don't know. That's what I'm trying to find out. So, if I were to take an area model, I know that a side length has to be 45, but I don't know what the other side length is, and I know the total amount has to be 413. Well, I could do 45 times, I don't know, let's say times 2, because I know 45 times 2 is 90. So that's going to give me a piece of it. So 413 minus 90... Alright, I know I can fit another 90 in there. I know I could fit 180 in there. So let me do that. So 45 times 4 is 180. So there's another piece. Not all of it, but a bigger chunk. Subtract that. So it's 3, 4, and 2 times 1 is 1. Alright. I can't fit another 180 in there, but I could fit another 90. So let me do another... Extend that out. 143 minus 90. 14 minus 9 is 5, so 53. And I can fit one 45 into 53. It's not going to be all of it, but it's going to be part of it. Alright, 45 subtracts. So 53 minus 45 is going to be 8. And I can't fit any more in there, right? So the 8 is going to be my remainder. So 2 plus 4 plus 2 plus 1. So that's going to be 9. And then with my remainder of 8. So 9 remainder 8 is going to be my answer. And when I look at what we did before, in fact, 9 remainder 8 was the answer that we got. So sometimes this area model approach is a little bit nicer and does work because we can just kind of do it in little pieces and little chunks until we figure out what it is. So let's do one more example, and then we'll get some practice with our actual assignments. Alright, so 1,980 divided by 55. So again, how many 55s are in 1? How many 55s are in 19? How many 55s are in 198? I don't know. So can I use this area model approach? It's almost like a reverse area model approach, I guess. But I know that 55 has to be one side length. I have to figure out what the other side length is going to be. I know the total amount is 1,980. Alright, so I'm looking for some piece that fits into 1,980. That's a multiple of 55. I could do times 1, times 2. I could make the T-chart, but let me just go with what I know. Let me make it easy on myself. I know that 10 times 55 is 550. I know that fits in there. Let me subtract out 550. And I know that I can do that again. So another 10. Alright, so let me extend this out because it's obvious I'm going to need more space. And I could do that another time. Now, It's okay if you saw this in fewer steps or you took more steps. Maybe you did it 55 at a time. That's okay. Or maybe you saw it, you did it in less steps than me. That's okay too. So I'm going to take out another 550. All right, and then maybe at this point I remembered that 55 times a certain number gave me 330. Maybe I could estimate to get there, or maybe neither of those. Maybe I'm just going to go off of trying to figure out what I know. So I know that 2 times 55 is going to give me 110. So the beauty of this is that you can do it in as many or as few steps as you want. Some people will do it in 2 or 3 steps, some may do it in 10 steps, and that's perfectly okay. There's nothing wrong with either of those. So I might recognize at this point that I could do this times 4 and get 220, but maybe I didn't. Maybe I didn't notice that and just did it 110. Ended up with another 110. Oh, there we go. And now I can finish off my array. And so what I have is 10 plus 10 plus 10 plus 2 plus 2 plus 2. That's 10, 20, 30, 32, 34, 36 is going to give me my answer. And when we look back when we did this with standard algorithm, in fact, we got 36 as our answer. So again, just another tool in your toolbox. Let's go back and review our objectives and make sure that we've completed everything for our learning today. Content objective, I can accurately use the standard algorithm for division. And again, they're wanting us to be able to do a 4-digit divided by a 2-digit. They're wanting us to be able to do a 4-digit divided by a 2-digit. And so we actually did that with 1,980 divided by 55, so we have successfully completed that. I can explain my process for using the standard algorithm for division, and it's the same as a 4-digit by 1-digit, which is does McDonald's sell cheeseburgers? And you could put rare if you want, but the process is exactly the same as what we already knew. So the patterns allowed us to see that it's not really any different. It's just more difficult numbers, but we have additional tools in our toolbox to help us with that. So check there. What is another way to solve the problem? Well, we did it with inverse operation or by fact families. We did that with modeling, both in groups here, modeling with base 10 blocks. We did area models, reverse area models, and of course standard algorithm. And so that also answers our sentence stem. Another way I could solve this problem is by using any of these other methods. So hopefully this helped, and definitely pause the video, go back, rewatch as much of it as you need to in order to fully understand this. And of course, I'm always available to help you if needed.